So for those who attend the first talk in this room, I want to remind a couple of things, which are the code of conduct that we have, especially for the room, is different from the FOSDEM one, so I encourage you to go on the page and read it out. If you're a developer, we would love to know your opinion, and try the survey from bit.ly/FOSDEM 17, all in upper cases. And from earlier presentations, we encourage you to try the nightly version of Firefox, which can be downloaded from nightly.mozilla.org or mozilla.org/nightly, whatever is easier for you. And we are trying to find out what motivates you to contribute to open source. So I invite you to complete another survey. We always survey these days at bit.ly/why-open-source. Our next speaker is Nicolas Strani, and he's one of the Mozilla lovers, and one of the few French people that really understand what GAP is. I don't know, I'm feeling bad now. And also he created the API app, using SpiderMonkey and the server since 2006, without 6 only, a long time. And he likes to ride a unicycle motorcycle. Welcome.
Hello everyone. So today I'm going to talk to you about embedding and maintaining SpiderMonkey in a large-scale project. After a quick introduction about what is SpiderMonkey and about our team, I'll show you a kind of simple hardware example, maybe a SpiderMonkey. And then we'll see what comes next when you have thousands of bindings inside your project and that you have to maintain them and the pain that is going to be for you. And finally, last, we'll see how to make embedded life easier by making bindings more easily to implement inside your project. So, if you don't know, SpiderMonkey is Firefox JavaScript engine. It can be used in standalone projects to add JavaScript feature bindings to a project. It has a C++ API, very nice team, and very good performance. There is a popular belief that V8 is faster than SpiderMonkey, but actually this is not quite right. And if you don't trust me, go see howifastYet.com and you'll see that SpiderMonkey is quite fast. About our team, I've been working with two very talented people for the past 10 years. And first we built a project called the Ape. By the time it was allowing you to do real-time communication inside the web browser when WebSocket didn't exist yet, and this was quite irritating. But now, there's WebSocket and nobody cares about this one. So we decided a few years later to build something else. We built Medium. Medium is a general-purpose JavaScript engine and rendering engine also. I'll talk about that a bit later. After building Medium, we had a great opportunity to try it in a production environment. A company called Concur, we did a real-time bidding server, which is used in the advertising market. And this server will have to handle 1 billion requests every day, something like that. And we tried it, we built it with Medium, and it worked great. So a few years later, we decided to open source it. Actually, it's been something like 6 months. It's out for everybody. So we'll see a simple words. So the idea is just to create a JS object robot, which takes a name as the first parameter, and which has one method, echo method. And when you will call this method, you should see something be printed, and like Jen says, hello world. Here is some sample code. I don't think you can really see what is going on here, but this is just to give you an overview. Here are the declaration you need to do in order to get your bindings done. The first thing is to declare what we call a JS class, which shows various information about your JS class. Then we have a list of the functions used inside your robot object. Here we have one method which takes one argument. Then we have here a robot structure. We will use this one to store the name of the robot to later retrieve it in the echo method. And then we have two functions to do. One which is the constructor of our robot, and the other is the echo method. Let's see what those methods are, those functions are doing. So the constructor is starting by doing argument checking and argument conversion. We just check we have the right number of arguments and match the type we're expecting. Sorry, we're not doing argument conversion here. We're only checking we have the right argument. The second part is about actually creating the JS object and storing a pointer to a robot structure which stores a name inside this JS object. And the last part of this code is actually getting the string given to the constructor, translate it to a C string, and store it inside a robot structure. There is not much more in this constructor. The second part is the echo method. Here you can see that just like for the constructor, we have all sorts of argument checking. Then we are retrieving the pointer to our robot structure, which stores the name, so we can then we can then convert the given argument, the string we want to print, and print also the name of the robot. This is not really complicated, but now imagine you have a lot of bindings to write, and sorry, I've been a bit too fast. You can notice in this short example that we have, it's essentially boilerplate code where you will just make sure the arguments are correct with a correct type, etc., and you will spend most of your time doing conversion between JavaScript and C or C++. And this is not really great because, you get quickly bored. As sign-up, just the example here were incomplete. They are missing a lot of stuff like the JS engine initialization, a bunch of error checking. I made the example short to fit inside the screen. So there's no JS exposure, so our object is not right now available to JavaScript, and there's no JS finalizer. I just needed to show a simple example. So now what's happened when you have thousands of bindings inside your project? Well, as I was saying earlier, you will quickly get bored by writing boilerplate code and doing conversion. It's very error-prone, and you can easily make mistakes, and your stuff will not work as expected or crash, or I don't know. When you have thousands of bindings also, you can see there's quite a lot of code for not that much, and you have to handle SpiderMonkey. There's a new release, SpiderMonkey upgrade. There's a new release every 6 months now, and each new release brings some awesome features, but also brings API change, and your code will break. So you have to update your thousands of bindings and all the argument checking, conversion, etc., to work with a new version. And this can be quite time-consuming when you have, you want to upgrade. This example was quite simple, but when you're working with more complicated stuff like asynchronous code or multi-threading, you have to get a deep understanding of how SpiderMonkey is working internally if you don't want your code to crash or stuff like that. Something also we didn't see with this simple example, but which will arrive at some point when you do your binding is that it can be tricky to correctly handle your JS object lifecycle and make sure it stays alive and it's not garbage collected when you don't want it to be garbage collected. And something we don't talk often actually is about documenting your JS binding. Most of the time people put documentation in the source code. But when you're doing bindings, it's kind of hard to write the documentation for your JS binding inside the C file. But that's not all. There's also other issue if you really want to embed SpiderMonkey inside your project. What's happened is that most of the time Embedder wants more than simple JS. When you have SpiderMonkey, the only thing you'll get is really basic JavaScript. You have no timer and nothing. Well, mass, date, and that's pretty much it. And all type and structure, but that's not much more than that. You'll need, yes, as I said, timer, socket, file system access, eventually modules, debugging facility. Usually when you start doing this kind of bindings, you will introduce new third-party libraries inside your project. So then the problem will be to build all of those third-party libraries. Because if your project supports different platform or configuration, it will be different for each platform and configuration. Most of the time you will have different workers or building script for each platform, but it can quickly become very hard to handle because those libraries need to be updated also at regular interval. So it's hard. So How can we make it in real life easier? Well, the project we've been working on, Medium, came up here, and with something called Ideal. We'll see that a bit later. So a quick word about Medium. Medium is a general-purpose JavaScript runtime and render engine. We'll see this. That's built on top of SpiderMonkey. We have two applications. There's Medium Server, which can be somehow compared to what is Node.js, but with less feature, let's be honest. And we have Medium Frontend, which is basically a window where you can draw inside it using Canvas API. Actually, it's a bit more than that because you have Canvas API, WebGL API, Audio API. There's also a layout engine inside. Just to be clear, this is not using HTML or anything like that. We just took SpiderMonkey and made binding for it and be able to render stuff on the screen. So for embedders, this is what may interest you more. We have two libraries, the two software built on top of those two libraries. LibMedium Core, which implements embedding hooks and some basic bindings, like socket, WebSocket, HTTP file, module, thread, and other stuff. And we have LibMedium, which implements bindings for Canvas, WebGL, Audio, and a few other stuff too. We also have a bunch of tools and help inside of our project to help building all the third party. This one is called Constructor. It's a Python script that will invoke different build scripts of your different third-party libraries. The great point of using Constructor is that you have all the build steps inside the same Python file that will invoke the right commands. And it handles various caching, so you don't have to build all the third party every time, and it's make building all the third party for different platform or configuration much more easier. The second tool, helper we have is called Class Mapper. It's a C++ header file which allows you to easily map a C++ object to a JS object. And while if you use Class Mapper, you will still have to write some boilerplate code like the argument checking and type conversion. But you have your object lifecycle that will be automatically handled. So if one of our objects is garbage collected, the your C++ class will be disrupted too. So it's avoid having many issues with garbage collection, but for simple case. We also have an experimental support for DevTools, which allow you to connect, as of today, Google Chrome DevTools. I'm sorry, Novella. But it was a bit harder to get this right, so we started with Google Chrome. Right now, it doesn't support a lot of stuff. You can inspect JavaScript objects, print stuff inside the console, but that's pretty much it. But in the future, we're really looking forward to implement to get the IPA done so you can interact with the debugger, put breakpoints, and etc. All this stuff. And the next thing, as I was talking earlier, is Ideal. Well, let's see what Ideal are. IDL stands for Interface Definition Language, and it's allowing you to describe your API. So here is a short example. The interesting part is that we have a constructor. We have a constructor that is taking a C string, and we have the echo method, which also is taking the C string. You probably will see a bit later how it works on the next slide. You've probably heard of WebIDL. They are used by Chrome, Firefox, Safari, and they use WebDL to generate their bindings. The great thing about generating your bindings is that you will no longer have to write boilerplate code, and all the argument conversion, type staking, etc. will be handled automatically. So that will save you a lot of time, especially when you will need to update SpiderMonkey, since you will only have to change your parser code to generate code compliant with the new SpiderMonkey version you want to upgrade to. Something great about IDL is also they are easily extendable, so you can build somehow your own flavor of IDL with what you require inside your project. And what we like about this is that, about IDL, is that we find it's a great place to put your documentation in it. First, because with the IDL code we have here, you'll be able to automatically generate the basic information for the documentation, and you will only have to write what's the description of your function, and arguments. Yeah. Okay. Before turning T, that's bad, but there's no tool available out of the box for doing this. all the browsers have their own ideal parser that is making the binding for us, but there's nothing available for embedders. Well, with Medium we tried to bring something, so it's very experimental, it's not quite perfect yet, but we are working on it, and we really hope that during this year we'll be able to get something that is working great. Let's see this simple example. So, as you can see here, we still have the ideal code, and when we give this code to a parser, it will generate us a class here. So I don't think you can read the code, so I will give you a general idea of what it's doing. So it will generate a GS robot class, and this class is extending class mapper. As I talked about earlier, this one will handle various stuff like your object lifecycle. And then it's also extending a GS robot base, which is where the embedder will do the actual implementation. It's on the right, but we'll talk about it a bit later. So, our GS robot class, this is only generated code. Here it's just a reader file, but I didn't put the generated code because it's way too big. The constructor here will only be invoked when the GS object will be created. We'll see this. We have three static methods. The first one is the actual constructor that is going to be invoked by the GS engine, receiving, all the GS arguments. The implementation of the constructor will do all the type checking argument conversion, and we will then call the constructor of the GS robot class, which will call the constructor of your implementation, of the embedder implementation in the GS robot base class. We then have the list method, which, as it says, lists the method available on your object, so nothing very specific. And then we have the register object method, which allows you to expose your GS object to the JavaScript engine. Here you can see that we have expose equal class. This means that we will have the robot class GS object available inside SpiderMonkey. Well, the global GS object. So let's see to what looks like the embedder implementation, what you will have to write. And you can see here it's way shorter than doing binding on your own. One of the great advantage here is that you will receive a C string when, you will receive always C argument converted to C in all the method or constructor. So here it's quite easy to implement our class. We have the constructor that is receiving the name, and we just save the name inside the property of the of our JS-related base class, the name argument here. We have a destructor that is going to be called when, as I said, the JS object will be deleted. Or if you delete your C++ class, your JS object can still live, but calling a method on it will raise an error. And here the destructor is only from the name. And then we have the echo method, which is way more easier than what we saw previously. It just does a printf with the name of the robot and the string we have. So as you can see, this can really make your life way more easier when you have to handle a lot of bindings inside a project. If I could sum up a bit all the things when you embed SpiderMonkey inside a project and you need to add bindings into it, the first thing you really have to do at all costs is to avoid doing binding by yourself and use abstraction as much as possible. So you can use IDL even if it's not finished, but maybe in a few months you can use it. Otherwise, you could use the class mapper in your file, or you can write macros, or I don't know, whatever suits you, but avoid at all costs writing your binding yourself. Always use SpiderMonkey debug builds, and this is something very important. SpiderMonkey has a lot of subtitles, and you really have to understand what is going on under the hood sometimes. And when you will use SpiderMonkey debug build, you will have a bunch of assertions when you're doing something that is not quite right, and this will help you to catch bug way sooner than otherwise, than the other way. There is a feature called the GC0, which will actually run the garbage collector much more often. And when you have issue about garbage collection with your object, enabling the GC0 will help you to really see where your issues are. It will crash pretty much as soon as you do something that is not good. Well, when your stuff is not correctly routed, sorry. I did SpiderMonkey at regular interval because if you miss a release, then the steps needed to get the next release inside the project will be higher, and you will need much more time to get it to get it inside the project. So try to update SpiderMonkey every 6 months at every release. You'll get nice feature, performance boost, and well, that's it. So if you need help, also, when you're doing the bindings, people of the SpiderMonkey are really great people. They're always here to help you and always here to give you good advice. And over the past 10 years, they helped us so much time. I can thank them enough to be there and be easily reachable. This is what's made us use SpiderMonkey actually, because having some people you can really talk to and that can help you to understand how SpiderMonkey is working is really a plus when you're doing your own project. That's it. I don't know. How much time? Okay, great. Okay. Just, whoops. Sorry. There are all the full concept with error checking and etc. are available on github.com/medium/FOSDEM. And you can find a project on medium.com or github.com/medium. Any question? Wow. Okay. Did you understand something? No?
I see from their looks that they are like, whoa, something like that. Some of them.
Okay.
Thank you so much, Dan.
Thank you. Bye.